So this question is quite a theoretical functions question using the domain, the range, and the inverse function. We're told in the question that g of x is equal to this logarithmic function, and we're told that x has to be bigger than -1. And we are trying to find g minus 1 of 3. Now, we know that g of x is the original function, if you like, and therefore g minus 1 of x is the inverse function. And the inverse is reflected in the line y equals x, which means that all of the x values become y values and all of the y values become x values. So if you're asked to find g minus 1 of 3, and what is that equal to, we know that that's the same as doing g of what is equal to 3. So that means the same thing. So we're trying to work out what is this x value when the y value is 3 of the original function, this function here that we were given initially, and therefore that's going to be the same answer as what is the y value on the g minus 1 of x. So we're going to have to use our GDC here to plot it, and we're working out essentially log 10 of x plus 1 plus 3 equals 3. So we're trying to work out for this g of x function, when is it equal to 3? So I'm going to go to my calculator and we're going to type in here log. So we're using the log function. Now, if we use this, it automatically puts a base 10. Okay, so we can just use the log button there, and it's x plus 1 plus 3. And I want to know when is that equal to 3. So I'm also plotting 3. And then I can see that we have this graph here. I'm just going to make my x values slightly smaller so that I can see what's happening. And we can see there's some sort of intersection. So we're going to look for that intersect somewhere around there. And we can see that that intersection happens at 0, 3. So it's actually on the axis, on the intercept. So that means that x is 0 in that solution, which means that g minus 1 of 3 is equal to 0. Okay. Therefore, you are asked to find what is g minus 1 of 3, and g minus 1 of 3 equals 0. I've actually already written it there. So that is my final solution. Okay. And then part B is g minus 1 of x has a horizontal asymptote, and we need to find what that is. So if it's a horizontal asymptote on g minus 1 of x, then on g of x, it would be a vertical asymptote. Because again, everything is swapped. Everything is the opposite. Okay. So on this original function that I've got plotted here, and I'm actually going to just get rid of the second one so that it's not so awkward to see, there is some sort of vertical asymptote. And we can see here, it's right there. It's where we've started. It's where the graph stops. It's this gap in the graph. So we're trying to work out what is that value. And the clue was actually given to us in the question right at the start. X has to be bigger than -1. So this value here, we think is going to be -1, but we can double check. So we could find a value, and we could find the value at -1. And it says here that there is no value of y at -1. So that would make sense that it would be an asymptote because it doesn't exist at that point. We could also use the table of values, and we can see for these values of x, if I keep scrolling down, we can find out what happens when x is equal to -1. And you can see again, from that point on, that is the error. So it's at -1 that this happens. So the vertical asymptote, the original graph, looks something like this. And it has this vertical asymptote at x equals -1, and that's the original function. Therefore, the new function is a reflection in the line y equals x, and therefore it's going to look something like this, and the horizontal asymptote there is going to be y is equal to -1. So the answer to part B is that y is equal to -1, which is the asymptote that I'm then using. So that's my answer there. In terms of the marks for this question, the first part is worth 2 marks. So one of those marks is for recognizing that the original function can be used when y is 3. Okay, that might be written like this, it might be written like this, but it's for recognizing that ability to swap between the inverse and the real function. And then the final answer is for recognizing that the function is equal to 0. And then the second part, 1 mark out of the 2 is for recognizing that the original function had an asymptote at x equals -1, and that could be drawn. You could write that the original function has an asymptote at x equals -1. You could write that in mathematical symbols. It's entirely up to you. And then there is a second mark for, answer mark for realizing that therefore the final answer is y equals -1.